In today's lesson, we will continue to graph sine and cosine functions. Specifically, we will be focusing on changes to phase shifts, and so we will also be looking at the periods. Let's start with the sine graph, y equals 4 sine, parentheses, 2x minus pi. Notice that this looks pretty familiar, except that normally when we see a phase shift or horizontal shift left or right, our coefficient of x has always been 1. So when we see a function like this, we're going to need to treat it a little bit differently in order to pull out our transformations and graph. So how do we graph this? The first step is to identify our transformations. Let's go ahead and start with our amplitude. Remember that our amplitude is always the number that's out front and represents the maximum height and the minimum height of our graph. Our amplitude in this case is 4. Now we need to look at our period and our horizontal shift, which we're now calling a phase shift. In order to identify our period, we need to determine what the number is out front of x. But in this case, the number is not in front of x because it's factored into the parentheses. So we need to take 2x minus pi, and we need to factor out this coefficient, factor out the 2. When we do that, we're left with 2 times x minus pi over 2. Now we can clearly see that the period is 2. And by doing this, this also gives us our phase shift. In order to determine the horizontal shift or the phase shift, we take this expression in the parentheses, set it equal to 0, and solve for x. So our phase shift is pi over 2. How do we go about graphing this? The first thing is to plot our amplitude. Since our midline is still 0, we can plot a height of 4 here and of -4 here, as this will continue to be our midline. We don't have any vertical transformations. Now what about this period? This period means that we will complete 2 full cycles in 2 pi. So how long does it take us to complete 1 full cycle? Well, in order to calculate that, if you remember from previous graphing, we take 2 pi and we divide it by this period. So that means that every pi we will complete 1 full sinusoidal cycle. Okay, now we need to break this into quarters. So what I'm going to do is I'm going to take pi, which is my complete cycle, and I'm going to multiply by 1/4 to figure out what my quarters are. So that's just pi over 4. That means that starting here, or actually, depending upon the phase shift, wherever we start, I'm going to add pi over 4 to get all 4 of my quarters. So let's go ahead and show that. Our phase shift is positive pi over 2. So that means that we're going to shift to the right, pi over 2, and that is where this curve will start. Then I'm going to add pi over 4 to this value, and that gives me then 3 pi over 4. If I add another pi over 4, that's 4 pi over 4, or just pi. So I have 1 2/4. I'm going to need 4 quarters. So here's my 3rd quarter. So this is 4 pi over 4 plus another pi over 4 is 5 pi over 4. And then one more would be 6 pi over 4, which reduces to 3 pi over 2. So what I've done is I've added pi over 4 to each of these values in order to get all my quarters. Now I'm ready to graph. When I'm graphing the sine curve, remember that we always start down here at 0. Our next dot travels up to the top of our amplitude and then back down to 0, to the bottom of the amplitude, and back to 0. And then now all I need to do is connect these dots, and I have my sinusoidal curve. Because this is continuous, it would, if I continued to draw quarters, it would go to the left to infinity and to the right to infinity. My maximum range would be 4 and my minimum range would be -4. Let's try one more. For this one, go ahead and pause the video, try this one on your own, and then come back, we'll do it together. First thing then would be to identify the amplitude, which was 2, and then we need to figure out our period. So remember, we need to take the expression that's inside the parentheses, and we need to factor out a 3 so that the coefficient of x is just 1. When we do that, we are left with 3 times x plus pi over 6. Pi over 2 divided by 3 is the same thing as pi over 2 times 1/3, which is just pi over 6. So now we know that our period is 3, and our phase shift will be negative pi over 6. And that's because if we set the expression x plus pi over 6 equal to 0 and solve for x, we end up with the opposite sign. Let's look at our periods. We're going to complete 3 whole periods in pi over 2. So how long will it take for us to complete 1 period? Well, if we take, in 2 pi, if we take 2 pi divided by 3, that's how long it's going to take us to complete 1 period, 1 cycle. Let's go ahead and figure out what our quarters are. So if I multiply this by a quarter, I would get 2 pi over 12, which reduces to pi over 6. So that means there'll be pi over 6 distance between each quarter. Now if I go ahead and graph this, my amplitude then is 2. So I'll put positive 2 there, negative 2 there. My midline is at 0. My phase shift is negative pi over 6. So that means I'm going to start back here. I'm going to shift to the left, negative pi over 6. If I add pi over 6 to that, my next point would be here at 0. So that's 1/4. If I add pi over 6, I get the second quarter here. If I add another pi over 6, that's 2 pi over 6 or pi over 3. And that's 1/4, 2/4, 3/4. My fourth quarter then, if this is 1 pi over 6, 2 pi over 6, 3 pi over 6 is the same as pi over 2. So what I've done is added pi over 6 to each quarter. Now I'm ready to graph. This is the cosine curve, so instead of starting here at the midline, I start up at the top of the amplitude. My next point comes here, and then all the way down, and then traveling back up. And now I'm ready to graph the cosine curve. And again, I have arrows representing that this curve would continue to wave up and down. Okay, let's quickly go through some reflections. Here's our sine function, y equals sine x. And then here we have a negative in front of the x, and we have a negative here, which meant we had a negative y. If we have a negative x, that means we reflect over y, and if we have a negative y, that means we reflect it over x. But if you'll notice that these two are exactly the same, which means we have an odd function, and this can help you in your graphing. Let's examine the cosine function. Here's our typical cosine function, and notice when we have a negative in front of the x, which means we reflect over y, these actually don't change. But when we have a negative in front of the function, which means that we had a negative y, so we're reflecting over x, it does change. So keep these ideas in your notes. The cosine is an even function to help you with your graphing. Let's go ahead and go backwards. Let's write the equation of a sine function. This really isn't too difficult, with the exception of the period. You have to think about this for a little bit. Remember that 2 pi divided by some value will actually equal our period. So we know that we're completing 1 full cycle in pi. So how do we solve this? Well, using cross multiplication, we end up with 2 pi over pi, which reduces to 2. So this is the number that will go in our function. If we're writing our function then, we have y equals an amplitude of 4, and then we have sine 2. Since our phase shift is positive 1/5, we know then this would be negative 1/5. We can write it like this, or we can distribute the 2 into the parentheses to write it like the two equations that we previously graphed. Go ahead and try the next one on your own. So first off, let's look at our period. 2 pi divided by pi over 4 is the same thing as 2 pi times 4 over pi. The pi's then eliminate and we get 8. If we go ahead and write this function, we have y equals 1/2 sine 8 times x plus 3, since it's going to be the opposite sign. And again, we can leave our function like this, or we can distribute the 8. And this concludes our lesson today on graphing additional sine and cosine functions and really focusing on our phase shifts. So now, hopefully, you are able to put all the different transformations together in order to graph a complete sine or cosine function.